All right, this is Project Test 5. This is the first video and it's problems 1 through 10. The price is in thousands of dollars, and by the way, that's important. So our x-axis is in thousands of dollars of 304 homes recently sold in the city are summarized in the histogram below. Okay, so we have 304 homes. Based on the histogram, which of the following statements must be true? The minimum price is 250,000. Notice they took the 250 right here and multiplied by 100,000 because 1,000 multiplied by 1,000. So that's why it's 250,000. And the answer is no. It's a possible answer, but probably not the best answer. We'll leave it here as a question as a possible answer. And the reason it's not necessarily correct is the minimum price could be anywhere between 250,000 to 500. We just know that it's somewhere within that block. We don't know exactly where it is. The maximum price they're saying is 2,500,000. Once again, they just multiplied by 1,000. They added 3 zeros. And once again, just like on the lower side, it's possible, but not likely because it's somewhere between 2,250,000 and 2,500,000. We don't know where it is, but it's somewhere in that block. So A and B are probably not going to be my best answers. Then they asked for the median price. Well, the median is the 50 percentile. So we're going to take the 304 homes, and I'm going to divide that by 2. And when I do that, I end up getting 152. So somewhere between the 152 and the 153rd, between those two is where the median price is. All right, that's the middle number, and all I did was just take 304 divided by 2, and it's 152. So if we get an even number, you're going to have to go up 1. So 152 to 153, in between those two numbers is where the median is. Well, I have 38 here and I have 120 there. So that adds up to 158. All I did was take the 38 and add the 120 to it. And so that sums up to 158. So this is 158 homes were below 750. Well, 158 are below 170. That means 152 and 153 are also below the 750. So the median price is below 750 because once again, I needed a value between 152 and 153, which falls in this bin. It fell within this bin. And since it, even though I know this went above it and went all the way to 158, this is the first bin that crossed over the 153 range. So it had to be within that bin. All right, so that's problem number 1. Problem number 2. As part of a study on the relationship between the use of tanning salons and the occurrence of skin cancer, researchers reviewed the medical records of 1,436 people. The table below summarizes tanning booths use for people in the study who did and did not have skin cancer. Of the people who had skin cancer, this is really important, of the people, so from the group that had skin cancer, all right, of the people who had skin cancer, what fraction used tanning booths? So we're going to have skin cancer in the denominator, skin cancer, and then we're going to have the intersection of skin cancer and tanning booth in the numerator. Okay, so in the denominator, skin cancer, well, that's this group. Well, we had 896 who had skin cancer. And then we were talking about using a tanning booth. And we have this intersection, so we end up with 190 over 896. Our answer is letter B. All right, moving on to number 3. A researcher is conducting a study of charitable donations by surveying a simple random sample of households in a certain city. The researcher wants to determine whether there is convincing statistical evidence that more than 50% of households in the city gave a charitable donation. So they want to check that more than 50%, that's going to be important, gave a charitable donation in the last year. Let P represent the proportion of all households in the city that gave a charitable donation. All right, so real quickly, I can get rid of D and E because we're going to be looking for our null hypothesis to be an equal sign. So we know the null hypothesis, HO, P equals 0.50, all right, equals 50%, and HA, P, and 0.50, but they said more than, so that means I need a greater than symbol, so this is going to be letter A. Number 4, a company determines the mean and standard deviation of the number of 6 days by its employees in a year. Which of the following is the best description of the standard deviation? All right, let's look at the formula real quickly. So the formula real quickly is going to be the summation of x minus mu squared over n. So we have individual values minus the mean over n. Well, this distance is an average. So it's the average number of 6 days for an individual minus the mean of the company. So approximately the mean distance, that's the distance between the number of 6 days taken by an individual, this is the part by an individual, and the mean number of 6 days by employees, by all employees. Well, that's the mean of the population or the mean of all employees. So letter A is the best. And once again, it's because this is the individual and this is the population and it's the average of that distance. All right. So that's number 4. Number 5. In one region of the country, the mean length of stay in hospital is 5.5 days with a standard deviation of 2.6. Because many patients stay in the hospital for considerably more days, the distribution of length of stay is strongly skewed to the right. So basically, we have a strongly skewed distribution. Consider the random sample size 100, that's important. Taken from the distribution with mean length stay X bar recorded for each sample. What is the following is the best description of the sampling distribution of X bar? Well, the nice part is X bar will never change. The mean part will never change, so it's 5.5. Well, we have 5.5 on every single one of the answer choices. So that didn't help out a lot. Okay, so now we need to be very careful. They say sampling distribution of X bar. So that's sampling distribution of the mean, and the standard deviation for X bar is simply the standard deviation divided by the square root of n. Now, if they had asked for the standard deviation of the sample, this would just be that value right there. It would not have changed. But because it's the standard deviation of the X bar, or the standard deviation of the sampling mean, it's going to be 2.6 divided by the square root of 100, which is 2.6 over 10, and that equals 0.26. So my answer is E. And by the way, X bar becomes normal. The distribution of the mean is normal for n greater than or equal to 30 by CLT, or central limit theorem. Okay, so it became normal by central limit theorem. So that's why it's no longer strongly skewed. Now the distribution of the sample will be strongly skewed. With the distribution of X bar, the distribution of the means will become normal by central limit theorem. Very important distinction there. Number 6, a local television show news station includes a viewer survey question about a current issue at the beginning of every evening broadcast. So we have a local TV show or local TV news. Viewers are invited to use social media to respond to the question. The results of the survey are shared with the audience at the end of the broadcast. In relation to the opinion of the population of the region, which of the following is a possible reason why the results of the survey could be biased? Viewers with strong opinions about the current issues are more likely to respond than our viewers without strong opinions. Yes, we have voluntary response bias. Very possible there because they were not randomly selected. Anyone could call in. So number one, definitely a possibility. So we like number one, that's true. The opinion of the viewers of one television station are not necessarily representative of the population of the region. Yes, we have a problem here of not sampling the entire everything. So we have under coverage here because we didn't cover all TV watchers. So that's true. And viewers with access to social media are not necessarily representative of the population. That's true. That's also under coverage because not everyone has access. We leave out part of the population. So 1, 2, and 3 are definitely true. In fact, the people who watch news may not be representative of the population. So, but in this case, 1, 2, and 3 are all true. And so our best answer is E. Number 7, a graduate student conducted a study of field mice in rural Kansas. The study obtained a sample of 100 mice and recorded the weight in grams of each mouse. After the measurements were taken, it was discovered that the scale was not calibrated correctly. The student adjusted the 100 recorded measurements by subtracting 3 grams from each measurement. Which of the following statistics for the weight in grams of the field mice has the same value before and after the measurement? So basically, we had each individual value, which I'll just represent with an X, and we subtracted 3 from it. Okay, so measures of center definitely change by the constant. When we add and subtract constants, measures of center change. So measures of center change. Just from a logical standpoint, will the value of the first quartile change? And the answer is yes, it's going to go down by 3, as will the third quartile. So hopefully we're working with this one. And sure enough, we have the interquartile range. And the interquartile range will not change. Why? Measures of spread that means range, interquartile range, standard deviation are not affected by adding or subtracting, are not affected by adding or subtracting a constant. They are impacted by multiplying, but not adding or subtracting. And if you think about this, let's just say the first quartile range happened to be originally at 11 and the third quartile range happened to be at 15. Well, if I subtract this distance right here, 15 minus 11 is 4. On the other hand, they are weighted wrong, so this is really 8. This is 12. 12 minus 8 is 4. So consequently, the measures of spread do not change when you add or subtract a constant, but the measures of center will. All of them change. Every single one of them changes when you multiply by a constant. However, z-scores do not. A statistician proposed a new method for constructing a 90% confidence interval to estimate, be careful, the median of assessed home values in a large community. To test the method, the statistician will conduct a simulation by selecting 10,000 random samples of the same size from the population. For each sample, a confidence interval will be constructed using the new method. If the confidence level associated with the new method is actually 90%, which of the following will be captured by 9,000 of the confidence intervals? This 9,000 is basically 9,000 over 10,000, which would be 90%. So 90% of the time, we're going to capture the true population, and be careful because they tricked you here. True population median. We could have gotten rid of the sample because we never make inferences about the sample. It's going to be the population, and it's the population median that they're interested in this time. No, we have not learned how to do this. They've constructed a new method. This is something we don't do, but I guess it's technically possible. Number 9, the distribution of monthly rent for a one-bedroom apartment in the city is approximately normal with a mean of 936. And the standard deviation equal to 61. A graduate student is broke and is looking for a one-bedroom apartment and wants to pay no more than $800 a month in rent. Of the following, which is the best estimate of the percent of one-bedroom apartments in the city with a monthly rent at most of $800? So he wants to pay no more than $800. So remember, this goes to negative infinity and positive infinity in a theoretical nature. So we want the probability that X is less than 800, which is a probability that Z is less than 800 minus 936 over 61. And we can do this as a normed CDF. So doing it as a norm CDF, second vars, normal, CDF, my lower bound is negative infinity. My upper bound is 936. Excuse me. My lower bound is negative infinity. I just put a bunch of negative nines in there. My upper bound is 800, because that's the upper part of my shading. My mean is 936. And my standard deviation is 61. When I do that, I get 0.01289. So about 1.3%. So the best answer for number 9 is A. All right. Number 10. A news article reported that college students who have part-time jobs work an average of 15 hours per week. The staff of a college newspaper thought that the average might be different from 15 hours per week for their college. Data were collected on the number of hours per week for a random sample of college students at the college who have no part-time jobs. The data were collected to test a hypothesis. Mu equals 15, or mu is different than 15, where mu is the mean number of hours worked per week for all students at the college. The results resulted in the data below. So we have a sample mean, the standard error, degrees of freedom, a t-statistic, and a p-value. Assuming all conditions for inferences were met, which of the following represents a 95% confidence interval for mu? Well, the confidence interval is going to have x bar plus or minus t star s divided by the square root of n. All right, so we have a few things in here that we need to be careful of, because they are being a little bit tricky here. First off, this is known as the margin of error. And while we've mentioned this several times, we usually don't have that many problems on this, but this is known as the standard error, which is what they gave you right here. So we know our X bar is 13.755 plus or minus. We'll come back to T star, but we're going to be multiplying by 0.707. All right? Because they gave us our standard error. They gave us our standard error of 0.707. So I need to calculate T star. Well, I start looking for my sample size, and I don't have my sample size, but I have my degrees of freedom. My sample size was actually 26. And I know that because my degrees of freedom is n minus 1. So if this is 25, then my sample size must be 26. So second vars, inverse T, my area, well, they want to construct a 95% confidence interval. So parenthesis 1 minus 0.95, close parenthesis, divided by 2, degrees of freedom, and they happen to give that to me just as 25. When I do that, I end up getting a 2.0595. So we know the first part's 13.755. Every single one of those have that. Then I'm going to take 2.0595 times my standard error of 0.707 that I got from the table. And I end up getting 1.456. So I end up with my final confidence interval as being 13.755 plus or minus the 1.456. So E is my answer choice for number 10. All right, thank you.